Hello, everybody. My name is Othun. I'm an MSOL student and a minor in Arizona at the same time. And today I'll be talking about GVAL, uh, natural language generation evaluation tool or framework that uses GPT-4 to increase natural language generation evaluation and gets it closer to human alignment. So let's go ahead and get started. So first of all, what is natural language generation evaluation and why is it important? Natural language generation evaluation is the practice of quantitatively or qualitatively measuring the output of natural language generation systems. This evaluation is essential for the implementation and improvement of machine generated content. Think essays or summarizations that you can do on ChatGPT, chatbots, sentiment analysis, and multiple other use cases that we see today and some that we haven't even explored yet. Now, the quality of natural language generation is measured by comparing the output of the machine to human output in several different cases. This is because the human language is redundantly natural language, right? Now, there's existing metrics, for example, BLEU and Roach, that are a lot simpler than utilizing an LLM. However, they have low correlation with human judgment, at least relatively to what we're seeing now with tools such as GVAL and other methodologies that we'll be seeing in a couple minutes. But basically, in simple words, what we want to do is we want to evaluate how good a computer is at writing like a person. And the better we become at evaluating it, the better we can become at improving it. Now, there's mainly four, and with LLMs, five existing NLG evaluation buckets, and each bucket has a couple different methods. Ngram based is the simpler, it just measures lexical overlap of the summary of a text over the text. So basically, the repetition of words, and it's a lot more mathematical. So it cannot measure the quality of the summarization. Now, embedding based is focused more on the semantics. So not necessarily on the words repeating each other or overlapping each other, but the meaning of sentences altogether. But it's not as accurate as other models. Task specific methodologies measure the quality of text tasks and are very task specific. The problem is that they are not generalizable to measure multiple different tasks like we can do with GEVAL. And the most developed is the unified methodologies that have a pretty good grasp or a pretty good closeness to human evaluation uh, metrics. However, they're not as close as GVAL or LLM evaluation because of, at the end of the day, it's still uh, referencing a baseline when doing the evaluation, a baseline that has been previously trained on, instead of measuring the output based uh, on its own training data like LLMs can do. This is a bit of a deeper dive into some of the evaluation methods. You feel free to stop the presentation right now if you want to look more into them. But LLMs are highlighted in green. Ngrams are the beige, lighter beige. Unified is the blue, UniEval, and then the lighter orange are the task based, and the gray ones are the semantic methods. So what is different about GVAL and how does it framework differ from anything else that's out there. So we start with the prompt with the definition of evaluating the task and criteria. And what's really special about it is we ask the LLM, in this case GPT-4, to generate a chain of thought, which means we ask it to develop instructions on for himself or for itself on how it's going to do the evaluation. This way, it kind of replicates the human thinking process, and it comes out to having an increased score function because one, it standardizes the way it's going to do the evaluation of that summary or of that dialogue, and um, after that it's just doing the scoring that calls the LLM and calculates the score of the content of the summary, and we calculate the score based on a grid with different evaluation metrics. This is just a little image from the paper that kind of goes over what the process looks like. So you have the task introduction, the prompt, and the evaluation criteria, which are given to the LLM. Then we ask the LLM to create the evaluation steps or the chain of thought. Afterwards, we give it the input content or the context, so the full article, and we give it the summary or what we want. And based on an evaluation framework, it can come up with a score which turns out to be significantly closer to human scores compared to other baseline methods. So we evaluated, or the paper evaluated 3 different tasks to compare to other methods. One of them was summarization of text, measured with the SumEval benchmark. Second was dialogue response generation, measured with the topical chat benchmark, which is basically the ability to have a conversation like a chatbot. And third, hallucinations, which is the ability to stay on topic of these conversational tools. And this was measured with the Quacks benchmark, which is basically it asks questions and it makes sure the questions can still be answered with the conversation that's going on. Now, each of these benchmarks is a standardized set of data previously evaluated by humans, and it serves as a baseline for comparison, since we're trying to replicate human natural language. Just for a little bit more context, GPT-4 was set to a temperature of 1, which would increase the randomness of the generation of results. This increases the variation in response. We didn't just want to have one integer, but there were 20 experiments performed for each test in order to get an average based on to increase the accuracy. Now all the scores range from 1 to 5, and to increase randomness and avoid the only integer responses, as I said before, the evaluation was based on an assignation of probability to each score from 1 to 5, and then getting an average instead of just saying 3 in this case. If 3 is the most likely, it would assign 40% to 3, 20% to 2 and 4, and 10% to 1 and 5. This would get us a 3.1 or a decimal points, which would be more accurate for the purpose of this evaluation. Now, for summarization results, I won't go into the table details, but basically Ngram and semantic methodologies performed poorly, which are the first 7 rows that you see. And GEval4 surpassed all other metrics, which means in evaluating summarization results from LLMs, it is way closer to what a human would have rated that summary. In dialogue results, it's similar. Engagingness is high on similarity based methods, however, not high enough to surpass um, both LLM methods GEVAL 3.5 and GEVAL 4. And for hallucination results, we see similar results. We see BART score um, uh, surpassing the LLMs on Quacks, which is just one data set from CNN. However, for all the other correlation evaluations, the LLM, or in this case GVAL 4, which is the most advanced LLM, was the closest to human evaluation. Currently, GVAL 4 has an advantage over all the other reference-based methodologies, making it a great resource for natural language generation evaluation, since the closer we are to evaluating if content is good or not, the closer we are to improving it. Summarization testing was performed on GVAL 4 with and without the main key component here, which was chain of thought, to make sure that there was an advantage, and there was. And some future work is to continue evaluating prompting alternatives, not necessarily CO2, to improve evaluation accuracy, since there's a lot of unexplored space in LLM behavior and reaction. And I just wanted to highlight that the evaluation accuracy can be the next milestone to increasing content generation, human interaction with machines, chatbots, um, news content, and at some point content creation being automated and automatically evaluated. Thank you.